Good morning, Massimo.
Ciao, Andrea. Good morning to everyone. And thank you for your participation in this GM International webinar. Andrea, if you are agree, let's wait a few moments before starting our presentation to allow everyone to connect. The same time, some words about the topics, today topics that intends to give a general overview on intrinsic safety and on the device involved in this method of protection, where GMI has developed considerable experience over the years. We will examine the real application of the process industry involving analog and digital isolators and how this device can practically solve situations that are usually handled with more complex and expensive systems. I want to remind everyone that during our webinar, there will be an opportunity for attendees to send us their question through the question and answer features. We will try to answer your question live, but if we are unable to give a live answer, we will send you an email as soon as possible with the information you requested. Well, Andrea, I think we can start now.
Yes, better. Thank you. Thank you for participants, and good morning and afternoon to the ones that are in Eastern area. Massimo, it's your turn, please.
Okay, let me give some information to the speaker. As already mentioned, I have a pleasure to have with me Andrea. Andrea is Andrea Spoller is a global account manager at GMI. He has over 20 years of experience in the machine process automation market. His main area of activity is in the industrial control process in hazardous application involving signal condition and remote control and bus interface. He has great expertise in international relations in the automation sector and has consolidated his experience in Europe. Now he takes care of customers and markets worldwide. Andrea is a functional safety engineer from 2016. And I, Massimo Pagani, product manager and technical support manager at GM International. I've been employed at GMI for 11 years. And my main role is to receive and process customer technical requests and assist them in the correct choice of products to be used in their application. Furthermore, I collaborate with our research and development department for the implementation of new devices to be put on the market, and with the sales and marketing office to promote GM products worldwide. I'm a functional safety engineer from 2020. Well, some information about the company. GM International is an Italian company born from the experience of Elcon Instrument, and for over 25 years has been designing, engineering, and manufacturing a complete range of seal-certified intrinsic safety devices. Our products are used in automation packages such as DCS, ESD, fire and gas, marine, and so on, in various industrial sectors such as oil and gas, petrochemical, pharmaceutical, food and beverage, and railway. All our products are tested one by one and must conform to the strictest worldwide specification. GMI is located around the world with over 200 people who make up our staff distributed on all continents. We have product stock distributed in our main branches in Dubai, Singapore, Houston, and in other parts of the world. Andrea, okay, thank you. The next. GM has always been perceptive to market demand. For this reason, its products are innovative in order to get maximum customer satisfaction. The strong point on which GM International bases its activity is the complete pre- and post-sales assistance in order to lead its customer to find the best solution for their application and to assist them in the correct use of the product. In addition, all our products are entirely designed and produced in our headquarters in Italy and are tested in high automated process. The goal of our company is to supply and guarantee innovative and high quality products. All our products are tested one by one and must conform to the strictest worldwide specification. Our products are tested and certified by over 15 independent UV agency and laboratory. And they have certification available for different market application, Europe, America, Korea, and so on. And according to the new ESC 61508, the C certification of the product is no longer valid, is not supported by the systematic capability design certification. For this reason, all our products are designed to adhere to the functional safety management, seal-free systematic capability certification. Additional, over 10% of GMI employees are engaged in research and development of new technology. Many of our resources are invested in research and development department. In the following slide, you can see the wide range of products we deal with. Here we can see ES barrier, safety relay, galvanic isolator, multiplexer for temperature and digital sensor, seal-free power supply, termination board dedicated to the most popular PLC DCS system, our multiplexer, and so on. Furthermore, our company promotes advanced course of functional safety and safety in AX environment conducted by expert training. You can find all the information about it in our website. The last slide lists some of our main collaborators and customers distributed among system vendor, PCO, and the user. Well, Andrea, it's your turn now to introduce topics today.
Okay, thank you, Massimo, for this brief explanation about GMI. We are talking about intrinsically safe isolators and application. And this is a presentation divided in chapters. We have 4 chapters. And first is the protection methods and intrinsic safety concepts, just for the ones that are, let's say, are not aware about this full scope. And we have the first slide, which is, let's say, a poll. We want to launch this poll just to, say, engage a little bit yourself. The EX protection methods, what is the basic protection principle of intrinsic safety? If you know, of course, is only one of this. It's not a multiple choice, but it's just one choice. And let us know if you are aware about what intrinsically safe is in the market. I see a lot of different answers. Who say that most of them are not correct. Okay, so intrinsic safety is a specific application where it can be isolation, mitigation, segregation, prevention, containment. More answer from your side? I think maybe you can answer also if you want. Just try. It's not, of course, you're not evaluated. That is anonymous. We don't know who is answered what. Okay, we can stop, and we can, of course, maybe share the results. Of course, the only good result answer is prevention. Okay, so we can skip to the next slides, and here you have an example of what is the intrinsic safety, the technology. So protection methods are different. So how to power and read signal from the field device installed in hazardous server. There are different applications and the principles of segregation, where the hardware is encapsulated or immersed or pressurized into different cabinets on different enclosure. There is the containment. So the containment is flame-proof, the EXD typically, which is in the middle. You see the big aluminum case where of course in case of explosion, the device is inside, is protected. Or there is the prevention, so EXI, so the good answer prevention for increased safety or intrinsic safety, where the amount of energy is limited. Now we have more information here. So this is the area where we are. So when the unit is used, you can see that you have a hazardous area, or you have a simple apparatus like sensor, temperature sensor can be, or IS apparatus, any other device that can be installed in a hazardous area. Then you have the cables going out from the hazardous area to the safe area where the isolated barriers are installed. And then you have the connection directly with the control room. So the control room cannot be connected, or the PLC itself cannot be connected directly to the hazardous area unless it's provided by intrinsically safe inputs or output, or let's say cards. Only in that case, if it's not, the associated apparatus, the intrinsically safe barriers or isolators, there are different names in the market. Now we see what is also the difference between among these types. And the device is the suitable devices, of course, must be certified. There is also a situation where this is just a reminder, the associated apparatus can be installed not only in safe area, but also in hazardous area zone 2. So, but the output is basically suitable for going directly to the safe area. So, should we use this isolator in intrinsically safe application? They use in different cases, of course, when there are potential ground differences. Okay, so the digital isolator can eliminate completely these ground loops that affect your measurement, your power to the systems. And the isolator limits for intrinsically safe only application, limited the amount of energy. So the amount of energy in a hazardous application that is, in this case, will be lower than the amount of energy that can cause an ignition. Okay, so this amount of energy is lower than the minimum energy for the creating explosion. So an isolator is not only designed as a standalone apparatus, but is a component of the IS circuit. So, and this specific things, like as I said before, so the amount of energy I'm let's say, using for making circulating the current or for powering the devices, lower the minimum initial energy in exposure area. That can be is different from area to area, from of course gas to gas. So there are different isolation, these different modules, these isolators with the different technology of signals. So it can be analog input out, digital input output, can be signal converter from one signal to another type, suitable for your data acquisition hardware. Can be triple amplifier, serial line converter, load cell, so for weighing application, vibration for measuring vibration, frequency, temperature, flammable liquid presence, or smoke detector. There are different types. Of course, the most common can be an analog digital signal that are covered, or the temperature covered the 90% application. But there are specific applications where, of course, vibration, load cell are involved in the measurements. So there are an isolator. Look at the first, let's say, first concept that I mentioned. So it can be barriers or isolators. So barriers is just a device that isolates the signal one-to-one without any specific features, while an isolator can give much more features, like different range of input-output, the source sink current, so to the PLC DCS. So the card of the PLC DCS can be source or sink, and of course the device connected with must be the opposite. If the PLC is sink, the device, the isolator, must be source, the other way around. There are units that can have, of course, digital bus communication, like Modbus. Burnout is another fault detection. So if your sensor is or the wire is cut, you want to get a fault on that. Very high accuracy also is demanded by some application. Multiple isolation between input, output, and power supply circuits. The programmability of certain operating parameters, and also, of course, the installation is not the last not the least, of course, a feature, because maybe you need to install this device in the D-rail or specific termination boards suitable for PLC application. Okay, now we have the second chapter to introduce this method. I don't know if you have any question. Massimo, is there any question there?
No.
Okay. Okay, great. So we can continue. This last chapter regarding the different IS isolator solution application for AI, ODI, IDO, temperature loss and field bus. So we have another, of course, poll, but is not a question, just a demand of what you are using on your systems. Let me share this. What solution feature this one? Okay, this one can launch it. Thank you. And maybe what solution do you usually apply if you use intrinsically safe isolators or you use Zener barriers? Those are the, let's say, the main difference when you use external apparatus. Or maybe your PLC DCS you're using is already equipped with intrinsically safe inputs. Or maybe you use other application like EXD or EXP, where the barrier is not required. This is also information that important for us. If you want to just answer and tap what you are using, we can now. We're gonna stop it. I'm gonna stop it now, and we can share with you the maybe. Most of you use Zener barriers, okay. Some of you use intrinsically safe isolators. Some of you use PLC, and other, of course. The market is, of course, is different because if you look at of course, I'm not talking about the PLC DCS application, but the technology, of course, especially in American market, we see that most common is the application EXD, XP different. While in Asia, Europe, isolation or say the barriers or isolators of the external apparatus is the prevention methodology is very important. Okay, thank you for your answer. Maybe we're gonna give you some details here. So we have the solution where there are analog input modules where you can have typically the 4 to 20 milliampere current repeater. Also in this case, you can see the input. It can be different technology, different system, or the 2-wire sensor, or the external power sensor with hard communication. And the output is to the system, can be source or sink. As I mentioned before, different cards have a different technology, so we can adapt the signal to the PLC of the system. Application can be SIL2, SIL3. This can be used as a signal duplicator. You see here that a sensor on the input can be connected to different cards, to 2 different outputs, okay? And this is the application for sensor 2, 3, or 4 wires. So in this case, with 2 wire, in the other case, with an external power. Then we have a solution also for analog with more channels. So you have more channels. This is not in the project. Basically, we see the demand for this mostly for OEMs customers, where you have a different channel with different output. This unit can be used also as one-to-one, but also as can be used as splitter or triplicate or quadruplicate also your signal. So one input and maybe 2, 3, and 4 outputs equal to the first one to send it to different systems. Maybe you have the application where there is also triple amplifier. This is a small, let's say, function inside the isolator. So you see that it's not only a simple isolator, but we add here the relay output to give some threshold on the low alarm, high alarm, window alarm, whatever, and Modbus output, and of course the 4 to 20 milliamps output. Different application in case you may need. Massimo, maybe it's your turn here.
Okay, let's see how analog input devices can manage a line fault. A 420 milliamp signal allows us to standardize the measurement and use it in a Moore standard. We know that in the range between 3.6 milliamp and 21 milliamps, the measurement is valid and correct. The analog barriers allow us to read a mirror signal that goes from 0 to a maximum of 26, 30 milliamps towards a PLC DCS system. In fact, the barrier has the main purpose of limiting the current in the loop to a non-dangerous level, which allows us not to generate a danger of explosion. These precise standards allow us to program our PLC to provide us with a line fault when the set thresholds are exceeded, or in case of using devices with programmable alarm threshold on board, to provide a single fault contact or cumulative fault to a DCS system. Now in the next slide, let's analyze how to obtain a correct system redundancy through trip amplifier devices. One of the typical applications which uses a redundant system with several devices is what we can see in the following slide, where 2 out of 3 redundant system of trip amplifier is used to activate our final element. This system and its redundant logic allow us to replace more complex system composed of safety PLC, allowing us to save more engineering cost. But let's see specifically the 3 trip amplifier devices each have 2 alarm relay outputs with individually programmable threshold, and each of them is SIL2. By programming all the alarm threshold of the trip amplifier in the same way and condensing in the way we see in the slide, the relay output in such a way as to compose a matrix of contacts, which allow us to obtain a SIL3 level from a component SIL2. To activate the final element, at least 2 of the 3 loops, sensor plus trip amplifier, must perform the same variable measurement in the field and correctly process the data. In fact, when at least 2 out of 3 sensors detect the same variable in the field, the related trip amplifier will activate their contacts, and consequently the final element is activated. How it's work? If one of the elements in the field fails, or if one of the trip amplifier fails, the 2 out of 3 redundancy allow us to maintain our safety function and process availability at high level. I repeat, this type of logic would be possible in another way, only by using a PLC system with redundant cards, having a considerable higher cost. This system allows us to achieve an high SIL3 safety standard with high process availability. Andrea, it's your turn for analog output.
Okay, thank you, Massimo. So we want to just, as you can see, show you some products, but the main purpose of this webinar is give you some application or the application where you gonna use a device like this. So the barriers cannot do that. Isolator is more, flexible from this point of view. So analog output, in this case, you see we have a solution with single dual channel with 4 to 20 milliamp and with hard compatibility that can be used also with the loop monitoring. Massimo, we explained a little bit more about the loop monitoring. And here in this case, Massimo, is your turn.
Yes. Also in this case of the analog output, let's see how a line and load fault is managed. In this case, it's the barrier itself, in addition to limiting the current and voltage towards the field to non-dangerous level, that carries out a real diagnosis of the loop towards the hazardous area. In fact, the internal circuit of the barrier is designed to provide us with a false signal when very precise thresholds are exceeded. But how is this fault reported to the system? There are two ways. The first involves the use of a fault contact, which is opened when the fault is detected and sent to a digital input card of a dedicated DCS system. In addition, a LED on the barrier, typically red, is turned on. The second method is the mirroring of the fault directly to the analog output card of the PLC. If the PLC is compatible with this system and the supervised analog output card is able to detect a change in impedance at its input, this system guarantees considerable saving in terms of cost, as it supervises the loop without the need to add a dedicated DCS system for this purpose. Now let's see how it's possible to manage a redundancy system for analog output type application. In this specific application, the management of two 420 milliamp signals towards the dangerous area is not a simple solution, as the two signals should be mixed or added in some way. GMI has developed a redundancy system through a special termination board, which takes the two signals coming from two analog output cards of two different PLC and mixes them through its own precise logic. In fact, we will have a main command signal called master and a support of it, a command called slave. The two signals arrive at the terminals of the termination board and at the input of an electronic switch placed on board it. If both signals are regular, the master commands the loop and drives our load in the field. When this master signal fails due to a line fault or because the relative analog output card fails, the current signal relative to it goes to zero, and the electronic switch placed on the termination board switches to the slave signal, ensure that the output load continues to be correctly powered. When the master signal is restored, the electronic switch on the termination board switches back to the master signal. Through this switching logic, it's possible to carry out redundancy also for analog output circuit. We can say that there are two ways, two different concepts for the use of redundancy. The one that looks at the safety of the process and the one that looks at the availability of the process. The two philosophies of redundancy are in contrast with each other, and the end user must choose which ways to go. GMI's analog output redundancy satisfy the concept of process availability, allowing our plant to continue its work even if one of the components in the field fails. GMI solution tries to simplify the redundancy logic to try to obtain the best possible result. It's your turn, Andrea.
Okay, thank you, Massimo. So we're going to show you the digital inputs, and so the digital input, we have solution with also for proximity of contact. With this case, show always the dual channel, but we have also single channel. And also it is keep it with the full loop monitoring and of course alarm output and duplicator functionality. This is the application for duplicator. So using a dual channel modules, you can duplicate your digital input to true digital output. digital output, or the second output can be used as fault. So your default is connected to a digital input card. This is a possibility. For default, we have also, we're gonna show you, probably is yours, Massimo, this one also?
No, it's yours.
It's mine, sorry. So we have the possibility of having this solution that repeats the proximity sensor with different level of current to your PLC. In this case, a different input level of current give you the information if you have a short or open circuit. We have a solution also with a channel for application where you have you can connect more signal together, and in this case you can have one-to-one functionality of, or you can have also it's a small device where the program, the configurability is quite simple, and you can connect the output to different, so the input to different output in order to duplicate, or maybe having some logic like AND or OR. Maybe I want
It's my turn in
the just one thing, Massimo. I want to just give you an overview. About the loop monitoring and the functionality, because more and more is required this line monitoring of the signal, either input or output, either analog or digital, in the PLC, in the application, especially in the user, is required more and more having the full line monitoring. So this is why we want to highlight this part, because it's a part of the functionality we have in our device, and all the new devices that we're going to develop are based on the line and load monitoring. This must work.
Yes, we focus on two particular digital input models that GMI has developed, SIL2 and SIL3, capable of transparently transferring the status of an Amour sensor or contact in the field to a supervised digital input card of a PLC. This allows our safety system to know exactly the state of the loop in the field. Furthermore, this transparency makes it possible not to use a dedicated DCS system for detecting a fault, as in case of using a normal digital barrier, which needs to interpret two contacts to understand the state of the input loop. But how does this transparency works? Well, through a network of resistors connected to transistors, the barrier output is able to provide the exact state of our input. According to the logic status of the input, 1 or 0, the device output sends a different impedance value to the PLC. In this way, the PLC, if correctly set, can recognize the state of the contact in the field. But what happens in the event of a fault detected in the field? In the event of a fault in the field, whether it's a short circuit or an open circuit, the transistor in series with the output loops opens, and an high impedance is shown towards the PLC digital input card, which is read by the PLC as a bad signal or a fault. This network of resistors at the barrier's output allows us to obtain a mirroring system of the fault towards the PLC. Well, let's see now some particular application involving digital input isolators. The typical application is where we have to isolate a voltage-free contact or an Amour sensor in the field, and in this case, we use the classic digital input barrier or an isolator. But what happens if in the field we have a voltage, 24 volt, 48 volt, 110 volt DC or other, and we have to signal to our system the presence or absence of this voltage. In this case, a standard digital input device cannot be used because its input front end is not available to accept external voltage from the field. In this case, we should use a digital output relay that is a device that, depending on the voltage that arrives at its command, activates or deactivates an output contact and communicates to a PLC DCS the presence or absence of a voltage in the field. The classic example could be the one where we need to communicate two PLC DCS systems placed in two different contexts. The digital output card of one of the two systems controls our digital output relay, while a digital input card receives the contact status of the digital output relay. What may be the main problem that can be encountered using a relay for this purpose? First of all, we have to keep in mind that usually a relay is designed to switch important value of current, while usually towards a digital input system, the current in play are very low, typically less than 100 milliamp. In this situation, we can face problems of oxidation of the relay contacts. Therefore, it's essential to choose a safety relay with golden plate contacts, which allow us as switchings tend to high conductive performance, even current lower than 10 milliamps. To deal with this problem, GMI has equipped most of the relays of the new D5000 series with golden plate contacts to make them available to this particular application. In addition, GMI has developed a universal device able to receive at its input different voltage level, 24 volt DC, 48 volt DC, and so on, selectable via this switch, while the output provides a free contact voltage, auto-coupled type, compatible with all PLC DCS systems, which ensure maximum conductivity even at lower current. We are often asked how to monitor a wet contact which is in the field. Of course, diagnosis of wet contact in the field is difficult. How it's possible to understand and differentiate the closed state of a contact from a short circuit. And again, how can we distinguish between the open state of contact and open circuit fault? This condition make us think that diagnosing wet contact from voltage in the field is impossible. But GMI, through one of its analog device, has studied a possible solution to overcome this type of problem and be able to provide diagnostic of a wet content in the field. In fact, using a trip amplifier and connecting it with a network of resistors to the contact in the field, we can obtain voltage level at the input of the device that allow us to discriminate one state from another. Furthermore, by programming our trip amplifier with intervention threshold, we can provide the PLC with a different state for each condition of the input contacts, being able to diagnose the normal operating state of the contacts from a fault state. Well, Andrea, we can go now with the digital output device.
Yeah. You have a question, Massimo, regarding the line monitoring and the load monitoring. So can you, let's say, spend a few words about the difference between line monitoring and load monitoring?
All our digital input devices are able to detect both line monitoring and load monitoring. Line monitoring means that the devices are able to detect when the line that connect the load and the barrier isolator is open. When load monitoring means that the device is able to detect if our load placed in the field have enter in a condition of a short circuit or for example, a condition of coil interruption in case of, for example,
so we can say that line is between the PLC and the isolator, and the load is beyond the isolator to the field.
Also.
Okay, hope we have answered to the question. So let's have a look about digital output functionality. So in this case, it's this device is loop powered through the control signal. Can be is that it has a different output. In this case, there are more outputs, two different selectable outputs for different current, because there are different. In this case, the main application is solenoid valve, where there is in need of current that is different from type to type, and this is selectable. We have also solution where we have different, more than two different selectable outputs on our device. L'application is C. We can go to the next one. Here is the same digital output but with the line monitor. So if you want to have line monitor also digital output intrinsically safe, this is a device that give you much more functionality. So the monitoring of the open and short circuit. The selective outputs here are 3 for different current and voltage application, and it can be chosen based on load you have. We have also solution with the multiple channel, 3 outputs on one device. Also in this case, this is selectable and configurable via PC. The number of selective parts are very, very important here. This function, this module has the Modbus interface that is suitable for full monitoring, full connection with the PLC that are equipped with the Modbus port. So let's have a look to the line fault detection for digital output. But first, we have a question, Massimo. Maybe let's have a loop. What is loop monitoring digital output isolator? That's right. We're going to answer to this question. Thank you. With this slide, I hope. Massimo, yes. Please.
Okay. Also for digital output modules, GMI offer models with onboard line and load diagnostics to monitor loops in hazardous area. We have different models. The models D5048S loop powered and D5049S bus powered, based on the impedance of the load in the field, are able to check the health of the loop, and in the event of a fault, generate a signal to the PLC directly to the digital output card, or through the classic voltage free contact to a dedicated DCS. DCS, being a loop-powered barrier for normally energized loads, is capable of monitoring the impedance of the input loop when the load is on. If it sees an impedance below 50 ohms, it detects a short circuit fault. And on the PLC side, it transfers the information direct to the digital output card, showing an high impedance, which translates into a loop current of less than 2 milliamp. When the impedance of the load, on the other end, exceeds 10 kilo ohm, the barriers sees an open circuit fault and, in the same way as before, show an high impedance to the digital card of the PLC. The signal of a fault can also occur through a voltage-free contact to be acquired through a dedicated DCS or through a fault LED placed on the front of the barrier. The D50 49S, on the other hand, being bus powered, provides a complete diagnostic towards the field, both in condition of load on and in condition of load off. Like the D5040AS, it can transfer the fault information directly to the digital output card of the PLC with an high impedance variation or through a voltage-free contact to be acquired with the digital input card of a DCS dedicated to the purpose. Well, now let's take a look at the redundancy problem also for intrinsically safe digital auto application. Basically, there are three ways to obtain the redundancy of this system with three different levels of redundancy. The first redundancy system involves all the elements that make up the loop, from the valve in the field to the intrinsically safe barrier to the PLC card that controls the loop. This is certainly the most effective and safest redundancy system, but also the most expensive, as to create the redundancy of all elements of the loop has considerable cost. The intermediate way would be to redundant all the device except the final element, that is the valve, for example. This means having two barriers and two cards controlling the loop. The main problem that arises in this case is that the redundancy up to the barriers forces us to mix the output signal to the barriers. This is feasible from the theoretical point of view, but first of all, it involves a derating of the intrinsically safe loop from EA to EB, which means that the final elements cannot be installed in zone 0, but only in zone 1. And also involve the difficulty to find a final element compatible with the safety parameters that are added, having to put the outputs of the two intrinsically safe barriers in parallel. This is certainly the most complex method to implement. The simplest and cost-effective way is the one proposed in the slide, where redundancy is obtained up to the digital output card of the PLC. After that, through two diodes, we mix the command signal coming from the two digital outputs card at the input of a single barrier that guides our final elements. This is the simplest system, as by not performing operation that adds current in hazardous area, there are no problems in terms of compatibility with the final elements, and moreover, is certainly the cost-effective solution, as the redundancy of the device reaches the PLC only. In the next slide, we encountered a digital out application where we were asked to be able to control a final element, typically a valve, by controlling it with two digital output cards. The final elements, normally energized, must be de-energized only if both digital output give the switch off commands. The solution studies to obtain an high availability to the process and to keep the plant always active in order not to have losses in terms of production cost, can be obtained through a double channel seal-free relay with the output contacts placed in parallel. In fact, in this way, the load will be de-energized only if both digital output cards give the shutdown commands. Of course, the solution is to disadvantages of safety, as putting the output contacts of a seal-free relay in parallel leads to an increase in possible dangerous failures. But thanks to the GMI's relay, we are still able to maintain a SIL2 level of the application and to obtain an high process availability. A different application where we were asked to create an high safety loop where the final element was de-energized when only one of the two digital outputs send a shutdown command. In this case, always using the same double-channel seal-free relay, the desired safety function can be obtained by placing the relay output contact in series. In this way, the seal-free level of the loop is increased to obtain the required function. This application makes us understand that sometimes it's possible to increase the safety or the availability to the process by combining low cost but very smart solutions, such as those proposed by GMI. Well, Andrea, it's your turn for temperature module.
Yeah. Before I want to just highlight this part. This is for safe harbor application. So we have a coil, which is say the current engaged in this case higher than, of course, this one. Where this one is for intrinsically safe solenoid. So a little bit difference between the two applications. So temperature, so solution with temperature, where you have the temperature sensor, either thermocouples or RTDs with different wire connection. Thermocouple is typically for two wire, while RTD can be 2, 3, 4 wires. Outputs are always 4 to 20 with different, for source sync, as always. And here there is also an alarm out and Modbus interface. What we can say that also here there is a full wire monitoring. So looking at this application, we can have a complete monitoring of the loop. A solution can be also this, where you have the temperature modules that is reverting one-to-one the signal from the field. So the thermocouples, RTDs, potentiometer can be replicated one-to-one to the system, where you have a card which is not accepting 420, but a resistance or millivolt signal depending on the sensor you're using. And this is a pure isolator, so without say conversion functionalities. We have here another possibility where you have a triple alarm. Triple alarm as a previous for 4 to 20, or triple alarm for temperature sensors with 2 alarms and 4 to 20 out and bus as well. Maybe Massimo, you want to spend a few words about the software?
Yes, a few words about the configuration software of the GM D5000 series barriers or isolators. Through this software, it's possible to configure and read all the parameters related to our devices and variables in the field, save and reload data and configuration in a local hard drive, monitor the variables in the field in real time to verify the correct functioning of the loop, and finally record monitoring session and save them in a file. The software is free and downloadable from our website and absolutely compatible with all Microsoft Windows system. In the slide, we see the configuration windows of our D5072S temperature converter, where it's possible to configure the type of input sensor, including thermocouples, RTD, potentiometer, or signal in millivolt. The output parameters are fully user configurable, and the possibility of creating a custom table is also available, where for specific application, the customer can create a table of input value for particular sensors, such as PTC, for example. And again, the monitoring session, where it's possible to check the parameters of the input variable and the health of the loop in the real time. All our D5000 series device can be configured with this software to perform their main functions or to obtain special function. Well, Andrea, we can go.
Okay, so other application can be waning. So the application where you have a tank with where you use in this case 3 load cell for waning applications. So it's a load cell, string gauge, a very strange, let's say, application of a product, but for specific OEM customers. And you have a load cell, 4, 6 wires. Can be also in this case we have 2 solutions. One is converted to 4020, so amplifying the signal from the load cell in 4020, or is repeating one-to-one the load cell to the systems. It's a unit configurable via PC with the Modbus ports and, of course, field calibration. There is also another application specific for vibration, is using motor application or in turbines. There are a lot of vibration, so the vibration monitoring is essential. And this unit is, of course, converting into, say, or amplifying to the signal to the data acquisition. Data acquisition systems are typically can be Bentley Nevada system, can be Blue Care. There are few system applications in the world that are using this kind of device. Massimo, maybe in a few words about this application.
Yes, this is a particular application are those involving devices such as accelerometers or vibration sensor. When these accelerometers operate in a classified area, they must be isolated through an intrinsically safe barrier. As in the slide, the D5062S isolates this particular type of sensor, transparently providing the reading system placed in the safe area with a waveform of the same level and frequency as that generated by the sensor, so that the system can read the signal correctly. It provides a fully floating DC supply for energizing vibration transducer, accelerometers, or two free wire sensor located in a hazardous area, and repeats the sensor input voltage in a totally isolated circuit located in safe area to drive vibration monitors or analyzer for rotating machinery control and supervision purposes. GMI can supply device to isolate and power the different type of sensor present in industrial automation and beyond.
Okay, so just to see if you are still there. Okay, we have what feature you use in on your let me feature of intrinsically safe application. If you're using single channel, it's a new single channel, multiple channel. If the feature you like is line monitoring, the one we explained here, from input, output, digital, analog, temperature, whatever. If software configuration is something important, if a seal is very important on the barriers, because we see demand is increasing, but maybe not on your side, maybe yes, or maybe you have some math function that are quite important. Okay, this is just let's say to collect some data from you, and let's say to stop a little bit for a while. This presentation is going to end in a few, let's say, few slides. No worry. Okay, thank you for answering. We don't quite to share this result, and we skip this part and we go immediately to the next part, which is next, let's say, Modbus interface. So yes, maybe is your part, Massimo?
Yeah. Yes, many of our devices use Modbus to communicate, but what is Modbus? Modbus is a serial communication protocol that connects programmable logic controls. It has become a standard in industrial communication and is currently one of the most popular connection protocols in the world among industrial electronic devices. The main reason for such as high use of Modbus compared to other communication protocols are designed with industrial use in mind. It's an openly published and royalty-free protocol, easy of installation and maintenance. It moves bits and words without placing many restrictions on producer. Modbus allows communication between different devices connected to the same network. For example, a system that measures temperature and humidity and communicates the result to a computer. Modbus is often used to connect a supervisor computer with a remote terminal unit in a supervisory control and data acquisition system. There are two versions of the protocol on the serial port and on the Ethernet. Each peripheral that needs to communicate via Modbus is assigned a unique address. Each of these can send a Modbus command, although generally only one peripheral acts as a master. A Modbus command contains the Modbus address of the peripheral with which you want to communicate. Only the latter will act on the command, although the other device also receive it. All Modbus commands contain control information which ensure that the commands arrive is correct. The basic command can ask an RTU to change a value in one of its registers, as well as command the peripheral to return one or more value contained in its register. Modbus RTU is an open serial protocol widely accepted due to its ease of use and reliability. Up to 127 modules can be arranged in a multi-drop network and monitored configured by a single master unit, as shown in the slide following picture. Each slave contains a table of parameters. Each of them is unequivocally identified through an address, and when a request make available its value for reading or writing. Complete diagnostic information can be retrieved through Modbus multi-drop RS485 protocol if a Modbus master is available on the system side. Modbus device communicate using a master-slave technique in which only one device can initiate transaction and the other device respond by supplying the request data to the master. A slave is any peripheral device which processes information and sends its output to the master. A slave does not send any message before the master requests it. As there can be several devices connected on the same RS485 bus, each slave must use a unique ID on the bus. What are the advantages of using Modbus communication? With a single Modbus RS485 interface, it's possible to connect and communicate with all the devices present on the same bus. Multi-drop connection is possible and communication can cover a distance of up to 1,200 meters. Another advantage is the possibility of not using a dedicated digital input card system to monitor alarms. This allows us to save to a significant saving in terms of cost. Real-time information on the type of alarm, on the health of the load and the line. It's also possible through Modbus a complete remote programming of the relay. In the next slide, we see what are the Modbus devices in the GMI portfolio. For all product categories, GMI provides devices that can communicate Modbus and be programmed through Modbus. In the next slide, we examined an application where a sensor installed in a hazardous area must communicate via RS485 with the control unit located in a safe area. This sensor, located in hazardous areas, must be isolated and powered through two barriers. One barrier will supply power to the classified area so that the sensor is protected and cannot generate sparks that can cause an explosion. The other barrier will have to provide isolation of the RS485 bus line so that it can connect with the unit control. The advantage of using this specific connection is the possibility of connecting up to 32 devices in multi-drop mode on a single bus, which allows us to form an integrated network or device with considerable saving on installation cost. When installing a device with bus interface in a hazardous area, there are two ES barriers that needs to be installed, a power barrier and a signal barrier. The signal and the power are two separate ES circuits, so they must comply with proper ES segregation distance. Well, Andrea,
Okay, thank you, Massimo. So we came to the conclusion. So we want to say compare intrinsic safety. So the application where GMI is with the EXT or purging or pressurization. So looking at the explosion proof and the pressurization, of course, we are say the intrinsic safety is more safe, more flexible, lower installation cost, and lower maintenance cost than others. So it's the only, say, intrinsic safety is the only technology for hazardous area application that permits allow a live maintenance. Okay, why of course the other system you have of course to disconnect because it's once you want to maintain, you have to open the cabinet, pressurize. You have to open the case, so it's completely different. Of course, there are applications where intrinsic safety is not allowed when you have a lot of currents, you have motors, compressor, whatever you have to drive. In this case, this is quite difficult or impossible to be used. Also, last point, then we finish, sorry, promise in this case. The use of isolator barriers is not sufficient for achieve safety, okay? That's very important. Because of course the isolator barrier must be compliant with the area classification. Also the field device must be compliant with the area classification. So there are safety parameters that must match. Also the cable are connected with. There is a temperature in the classified area. So there are a lot of things. So looking at this application, in this case, there are the safety parameters of the isolators must match with the parameters of the field device, and also the cable are connected with. So this is very, very important. We don't want to say give all details here, but available GMI, there is a tool, loop verificator, where you can verify if the device is suitable to be used with the field device you're going to apply with. So it's a very simple tool, and you please use it. It is not say certified device, but is of course is very useful for quick information. Last, so is regarding the Zener barriers. So of course the Zener barriers, we see that a lot of you are still using. They're very good. That are very good in cost, simple design, powered, but required, of course, hurt connecting with so the system must be grounded. It's very, very important in this part. While the isolated barrier don't require earth ground connection. It's more expensive in the beginning, but later in the application, it's the maintenance is definitely less, and it can be used also with devices that are not isolated. Okay, if you have any question and answer, please say now. What are the grounded sensor example for isolators? Oh, Massimo, we have a last question. What are the grounded sensor example for isolators? Oh, let's say I would say that the temperature.
Yes, typically thermocouple, I think.
What?
Thermocouple, I think.
Okay.
Yes.
So grounded sensor can be used only with the Zener barriers can be only with the grounded sensor, right? Yes. When they're not grounded, of course, cannot be used. Okay.
Typically, we don't know. We don't use a grounded sensor with our devices because intrinsically safe barrier does not have the ground to connect.
Okay. Any other question? Otherwise, we go on. It's already late. 12 time. So maybe we can remind you that information is available on the website. Other webinars are on the website. This webinar has been recorded, and as the other are available on our YouTube channel. And last poll, if we did, so we are measured also on this. So please take minutes to save how we were. So of course. don't your evaluation is very good, is anonymous, so we don't you can write what you like. Thank you for answering. Thank you very much. Thank you very much. We're gonna stop also this part. Last question. You will get the 10 certificates, and the record of webinars will be, as we said, will be available on our YouTube channel very soon. I think in 1-2 days. They also get the certificate. You will get within 1 week for sure if you participate at least 75% of this webinar. Okay. Thank you to all of you. And we're gonna now stop it. And just to remind you our, say, face, name, and email if you want to write us. Thank you, Massimo, and thank you to all our attendees.
Thank you, Andrea. Thank you to all our attendees, and we will see to the next webinar.
Thank you.
Thank you. Bye-bye.
Bye-bye. Bye-bye.